Welcome to 24 Hours Pass evolution of the data platform. We're really excited you could join us today to Martin Catherall's session, a lap around Columnstore in 2016 operational analytics. This 24 Hours of Pass event consists of 24 consecutive live webcasts delivered by expert speakers from the Pass community. The session will be recorded and posted online after the event. To access any on-demand session, please visit 24hoursofpass.com for all session links. My name is Johan Brattås, and I'm co-lead of the XLBI virtual chapter. I'm glad to be your host today. I have a few introductory slides before I hand you over the reins to Martin again. If you require technical assistance, please type your question in the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. And please note that there will be a short evaluation at the end of the session. Your feedback is very important to us, so please take a moment to complete it. It will appear in your web browser. Also, if there are any questions that we can't get time to answer today, Martin will get them sent afterwards, and he will probably be able to post a blog somewhere. I'd like to take a moment to thank our presenting sponsors, Microsoft, Amazon Web Services, Hortonworks, and Redgate. In addition, I'd also like to thank the supporting sponsors for this event, Hewlett-Packard Enterprise, SQL Server, and ScanDisk. For more than 25 years, ScanDisk has been expanding the possibilities of data storage. As a vertically integrated storage solution company, they are able to quickly deliver innovative, high-quality solutions with less time from research to realization. From handheld devices to hyperscale data centers, ScanDisk storage solutions make the incredible possible. The staging of 24 Hours of Pass would not be possible without their generous support, and they are the reason this event is available free of charge. Next slide. Make sure you explore everything else Pass has on offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. Next slide. This session is presented by Martin Catherall. He's a senior consultant at Rock-Solid SQL. He's a data platform MVP, Pass region mentor for the Apex region. He is a SQL Saturday organizer in South Island, New Zealand. He's a former leader of the Christchurch SQL Server user group, and you can find him on Twitter at Martin Catherall, and email martincatherall@rocksolid.sql.com. Go ahead, Martin.
Okay, thanks a lot for that, Johan. That was a great introduction. Yep, as Johan's just said, I'm he's introduced me as a consultant, but I like to think of myself as a product evangelist at Rock-Solid SQL, where I use their software to help our customers solve SQL Server problems. They've just led me from Christchurch, New Zealand, over to Melbourne. So I've broke some of my ties with the user groups over there. The community's getting greatly underway over there, and it's in capable hands at the moment. But that's not here what we're to talk about. We're here to talk about a lap around Columnstore and 2016 analytics. So let's get into this. Okay, now there's the abstract on the screen. I'm sure a lot of you have previously read this, so I won't read it again. But this is probably the 4th or 5th time I've introduced this session. And the session's kind of morphed over time to now be kind of a real basic presentation to introduce Columnstore from the ground up. So if you're got knowledge of SQL, maybe you're a developer, a DBA who've never dived into Columnstore previously for one reason or another, then this is probably a great place to learn about all the features. that came along in the first release through the second release, and now going into SQL Server 2016, which is less than a week away from launch. So at the end of this session, you should have a pretty good grasp of the basics of Columnstore, and be well armed to go on with the references that I'll provide at the end, and be pretty clued up and make good decisions about how to use it in your environment. Okay, so we'll do a short introduction about the about Columnstore, and then I'll introduce some terminology and take us through the various releases from 2012 to 2016 and some of the major improvements that were made. I'll mention some of the possible shortcomings and how people worked around those. Then I'll talk about the storage format and operational analytics, and also I'll provide a bit of an explanation about how Columnstore works under the covers, which is actually quite interesting and quite a novel way of doing things. And then we'll leave a little while at the end for questions, and like Johan said, if we run out of time, I'll answer any questions in a blog post or put them online somewhere, or we'll figure out what to do. Okay, so what is Columnstore? It's basically an indexing technology aimed at data warehouses, basically big tables where we're doing big scans over them, analytical queries, counts, aggregates, that sort of thing. It provides us with more compact storage, and because we've got more compact storage, we're able to query faster and break down the exact data that we need quicker. As we go through the presentation, this will hopefully become obvious to people. Now, you've probably seen this technology previously in other technologies, notably Excel, tabular model, Power BI. You may have downloaded large Power BI files to the desktop and then saved them and wondered why they're nowhere near the size of the file you downloaded. And that's basically Columnstore in the background. Columnstore's basically iterated over 4 releases, and it's now become a very usable feature. Initially, the uptake was slow, and we'll have a look at why that was. There's some analogies with traditional indexes, traditional clustered indexes, non-clustered indexes, but there's also some major differences, and I'll point them out as we go along. So kind of forget everything you know about traditional indexes, and let's talk about Columnstore. Okay, so Columnstore came along in 2008, and sorry, not in 2008, it came along in 2012. That was the first time Columnstore was introduced to the product. Now, there was a few drawbacks with 2012, and we'll get to them shortly, but apart from that, it didn't really have a great deal of uptake, and I kind of puzzled a bit about that. Maybe it's because it's an enterprise-only feature. Maybe people thought we've already got row compression and page compression and we just don't need to look at Columnstore, or there could have been other reasons. Row and page compression, yep, they offer a good comparison with row-based tables only, and we'll talk about row-based tables a little more shortly. So 2012 introduced a non-clustered Columnstore index. It also introduced a new processing mode called batch mode processing. And along with this new Columnstore technology came some new language for existing features. People started to talk about row mode and also row stores. And for people who are not really familiar with Columnstore, it presents a bit of a question, like what is a row mode, what is a row store? Well, row stores are basically traditional tables, kind of tables that everyone who manages databases, SQL Server, is familiar with. So we've never needed a separate term for it before Columnstore came along, because that was basically the only format we had. But now data can be stored in columnar format, basically Columnstore. So we need some language to differentiate a normal table or a traditional table from a column store. And that new language is in fact a row store. So that moves us on to batch processing mode. People also conversely started talking about row mode. Now, row mode is basically the mode that your operators run in when you look at a query plan. All those operators are running in row mode. They're basically one operator asking next for a row of data, and then it's having it passed back. Batch mode takes that to a new level with Columnstore. Each iterator can ask the next iterator for basically up to 900 rows of data at a time and pass them back to between operators. This basically achieves a lot of the performance that we can leverage with Columnstore, and quite a lot of that is due to the compression in the Columnstore format. So some terminology for us, or an explanation of how Columnstore works. With a row store table that we see here, and I'll just kind of draw an analogy between the two. With a row store table that we've got here, we've got quite a large number of columns. All the columns are between 4 bytes and 8 bytes, and the total of one row is 96 bytes. Obviously, there's a lot of rows that fit on a page, and there's 8 pages to an extent. So when we ask for a query, for example, the query on the right of the screen here, we're basically asking for 4 columns. But SQL Server, although it displays the 4 columns to us, it goes away and it reads in all the data that's contained on them rows, on those pages, and then discards the in-memory data that it doesn't need and just displays data to us. Now, that's relatively efficient, but it could be way more efficient. I mean, we're filling our memory up with data that we're potentially going to discard. So how could that be better? Well, instead of storing our data in a row-based fashion, we store it in column-based fashions. And as you might imagine, columns have got maybe more repeating values in them. For example, if you had a first name column, you might have the names Martin multiple times, Johan, Elizabeth, all multiple times. And so that provides a large degree of compression. So when we do our query that we've seen on the previous slide, we're selecting 3 columns from, I've got a 6-column table here purely because I couldn't fit 20 columns nicely on the screen like this. So we ask for 3 columns from our table, and straight away we eliminate the columns that we don't want. So we're not even going anywhere near the data that's contained in those 3 unwanted columns. And if we use partitions carefully, we can further eliminate more data that's potentially not needed before we actually use it. So straight away you can see that regardless of the compression, there's a massive amount of saving here in terms of processing, and the compression just adds to that. So just a graphical explanation really about batch mode processing that we've already talked about. We see the parallelism operator on the left of the screen, and that in a traditional row mode it would ask the stream aggregate for 1 row, and that would ask the index scan for 1 row, and 1 row would keep passing backwards and forwards. But in batch mode processing, up to 900 rows can be passed between these operators, making it hugely more efficient. So how do we tell if our operators are in fact operating in batch mode or row mode? Well, in 2012 we got a new property in the plan, and that's the estimated execution mode. Now if we're dealing with a row mode operator, we will see that the estimated execution mode is row mode. We can see that in the graphic on the left of the screen there as you look at it. And with a batch processing mode, we'll see that the estimated execution mode there is batch mode. When 2012 came out, potentially there wasn't much scope for mixing these. A lot of the operators didn't support batch mode, and that's got better through 2014 and has got better again in 2016. And now these can be mixed quite a lot. So in 2012, the non-clustered column store index was introduced. The promise was more compact storage, faster querying for certain workloads. Large data warehouse tables where there was lots of counts, aggregate queries, so on and so forth. Now a clustered column store, a non-clustered column store, rather like a non-clustered index, is an additional index built over the top of an existing table. The existing table could be a clustered index, or it could be a heap. You could build a non-clustered column store over the top of either with a simple create non-clustered column store index syntax, which we'll see shortly. Now, one of the massive blockers to adoption here was the index was not updatable. I remember looking at this technology back in 2012 and I was really, really excited about it. But as soon as we found out it was non-updatable, that was a bit of a blocker. We decided not to use it in the end, but people did find ingenious ways around this, which give it a bit more of an update. Like we said, very few operators supported batch mode, and so a lot of the queries fell back to row mode. So the potential benefits of faster querying weren't realized. Certain data types weren't incorporated into Columnstore, and no ordering of the Columnstore index is done. So this is one of the big differences between Columnstore indexes and normal indexes. There's no ordering. There's no like order them in ascending order or descending order. The algorithm that builds the storage pretty much compresses it in its own way. Now 2014 introduced the clustered column store index. Now the clustered keyword is not to be remember you don't need to have the clustered keyword in the index definition because the you do need to have the clustered keyword in the index definition because by default these indexes were brought in 2012 and the non-clustered keyword was the only column store index that existed, and therefore it wasn't necessary to put it in the syntax. So if you want a clustered column store index, you need to specifically say that. I personally think it's a good practice, even with clustered primary keys and clustered indexes, to include the clustered keyword so that people coming along afterwards know what your intention was to build. The clustered column store, unlike the non-clustered column store, is fully updatable. However, the non-clustered column store was read-only. Now, I mentioned in the previous slide that even though the non-clustered column store index was not updatable, people still found quite ingenious ways to work around it. One way which probably some of you may have thought of already was, well, if you can't update a non-clustered column store index on a table, well, why not just drop the index, update the table, and then rebuild the index again? And that's exactly what a lot of people did. A lot of data warehouses would be loaded, say in the middle of the night during a downtime window, and there's plenty of time to drop and then recreate the index. So that worked really well for a lot of people. Another quite good way of doing things was to simply load a staging table which mirrored the production table, the proper production table. So we load our staging table, which has no non-clustered index on it. The staging table is partitioned, and then once it's loaded, we rebuild the non-clustered column store index over the table, and simply place one additional partition at the bottom of the main table. So we're basically doing like what you would imagine with Lego bricks. It works really well if we've just partitioned by, say, date. We've got a new day's data, so we could switch in a new partition from, say, today or this week or whatever, just at the bottom of the table. A further way of doing it would be to have the main table with the non-clustered column store over the top, and then to have a duplicate table, which is simply a copy of the main table with no column store on. And so you load into that table and then do a union between the two tables. And that approach is really interesting because we're going to see it a bit later on, and explain how the clustered column store works and how the updating mechanism works behind the scenes. Okay, so 2014 gave us the clustered column store. Now there was no mixing of the two types in 2014. Kind of doesn't seem logical why you'd want to mix the two types anyway, but yeah, there's no mixing of the two. Batch mode and row mode supported again, and more data types were introduced in 2014, which give the clustered column store greater scope to work on tables with a greater amount of data types. The main drawback with this column store was that no additional constraints were supported on the table. So you'd build a heap, then you'd build your clustered column store over the heap, and then you couldn't put a primary key on it, you couldn't put any indexes on it, you couldn't put any foreign keys on it, and that was a drawback for a lot of people. Maybe if you're doing joins or something, it had a bit of a big impact there. But again, it worked quite well for some people. So it was a step forward in some ways, but maybe not as big a step forward as some people hoped for. Now 2014 introduced a new type of column store compression, and that was the column store archive compression. So if, for example, you've got a partition table and you've got some cold data, maybe some archive data, you could get additional compression on that partition by selecting the column store archive flag. So you basically saved disk space, but you took a wee bit of a performance hit to get the data that was in the column store archive format. 2016 built on that again, introduced the updatable non-clustered column store index. So yep, you can have a clustered column store index this time. There's no dropping it and rebuilding it, no switching in unless that's the architecture you've planned. Additional indexes and additional constraints are now supported on clustered column store indexes, which is a huge step forward. So you can basically now mix your data warehouse workloads with your traditional row-based workloads. Filtered non-clustered column store indexes were introduced, and again, more operators supported for batch mode. Another big step forward was that batch execution mode can now be accomplished with a single core. In the previous versions, 2014 and 2016, you had to have multiple cores allocated to your SQL Server for batch execution mode to be accomplished. This limitation is now taken away in 2016, so even if you're running Enterprise on a single core, you can still achieve huge improvements with your data warehousing queries and leverage batch execution mode. But one thing to note is that to achieve all these additional benefits, even though you might have restored an existing database to 2016, you must ensure that you change the compatibility level to 130, which is obviously the compatibility number for SQL Server 2016. So just watch that if you are doing a brand new install of 2016 and placing backups, restoring backups from previous systems, 2012, 2014, or even earlier versions onto that system. Make sure you update the compatibility level. So creating a clustered column store or a non-clustered column store, relatively easy through the GUI. There's a screenshot there of how to do it, creating a new index. I personally don't use this method a lot for any of my indexes. If I do, I'll press the little script button in the corner of Management Studio and script off my index and then run it through. So if we script it off, that will give us the T-SQL. We see there that the clustered column store index syntax at the top. And the main thing to notice about that syntax is that there's no column list. We simply create the clustered column store index on top of the entire table. So it basically consumes the whole table, and we don't need to specify a column list at all. Drop-in index, pretty straightforward. Creating a non-clustered column store index, we actually do need a column list here. We give it a name, the table that we obviously want to create it on, and then we place our column list after that, very similar to traditional indexes. And down the bottom there, we can see how we can create a filtered non-clustered column store index. And just to recap that the non-clustered keyword is actually optional. I personally always prefer to use it though. I think it shows your intent, what you plan to do. Some additional terms that you may have come across on your journey in Columnstore. You might have seen this in VersaPack. We mentioned some of these at the start, Excel, Tabular. And one of the things that I found a lot of people confused about is the marketing terms for these. And we hear in-memory analytics being talked about a lot. That's basically what I think about as the marketing term for Columnstore. So I think about Columnstore as being a technical term, and in-memory analytics as being the marketing term. And I basically put a definition there, but it's just the ability to run performance analytics on a transactional system. Other things in the in-memory space you might have heard about are in-memory OLTP. That's not what we're talking about here. That's a separate piece of in-memory technology involving placing tables in memory. We're specifically talking about in-memory data warehousing, or like we said before, in-memory analytics, which is Columnstore. So we'll have a brief mention of the storage format here. Clustered, in the sense of clustered column store, does not mean ordered, as with traditional clustered indexes. So when you create a clustered column store, please don't expect it to necessarily be in a particular order that you planned. Now the columns that we've seen in a previous slide, they are stored in row groups. Row groups have got a maximum amount of rows they can store. They can store up to 1,048,576 individual items that might be compressed or otherwise. That number is basically 124 squared. And if you do want to delve into some of the details of this, and we might have a look at these towards the end if we've still got time, there's some great information from another SQL MVP who comes from Portugal, Nico Nugenbauer. Now he has got a great set of libraries to investigate the storage formats and the underlying architecture of Columnstore. Called it the Columnstore Index Script Library, and it's available on GitHub, and I'll have a reference to that at the end. In addition, there's also some great DMVs and extended events available to give insight into the workings of your non-clustered and clustered Columnstore indexes. So let's talk a little bit about operational analytics. We've previously looked at our definition there, but one of the questions I often get is, well, don't analysis services cubes already do operational analytics? And yes, they do. But with cubes, most people set their cubes up to basically process once a day, maybe twice a day, on a particular at a particular interval. And so reading data, if you read it straight after processing, the data will obviously be fresh, not out of date, and your report will basically be up to date. But as the day progresses, your report becomes more out of date. Now this might be fine for some scenarios, and it might not be great for other scenarios. So most queue processing has two steps. First of all, we run an ETL to move data from our OLAP store into our data warehouse, and then we process the queue, which obviously uses the MOLAP model and means that we've got pre-aggregated data sitting there, gradually becoming out of date as we move throughout the day. Now, the MOLAP model obviously pre-aggregates our data on a schedule. Maybe with this new Columnstore feature, we can now move to a roll-up model, which is relational OLAP. And instead of using pre-aggregated data, maybe we can get our cubes to go back to our relational data store, not even our data warehouse, but straight to our relational data store, and run a real-time analytical query on our OLTP environment, meaning that we're getting real-time data and our reports are up to the minute, whatever time of the day we run them. So this is pretty much the crux of operational analytics. It's basically real-time data rather than possibly stale data. Now here's basically a slide to demonstrate how a traditional model would work. We've got SQL Server over on our left. On our right, we've got our BI analytics workload, and in the middle we've got our ETL job, basically transferring data from our SQL Server on the left, which represents our OLTP environment, to our SQL Server on the right, which represents our relational data store, and then has our BI and analytics built over it. Now we've got Columnstore, we can change that picture a little bit, which we'll see on the next slide. Some of the issues with this model, it's obviously very popular and used widely, requires two servers. It can be quite complex to implement. and more business as a demanding real-time data rather than out-of-date data. So how do we minimize that data latency for analytics? Well, we still have our SQL Server over on the left-hand side, as we did with our previous model. But now we've added a Columnstore index to the database, be that clustered or non-clustered indexing, and we can go straight to the database with our BI and analytics workload, or through our analysis services, whichever we choose to do. So we are getting data in real time from our OLTP system, which before our queries might have took minutes or hours to run. Nowadays they can run in maybe a few seconds, certainly an agreeable amount of time that people could wait for reports to process. So that's it. Real-time operational analytics is in that space. I mean, it may replace ETL for some people. Obviously won't replace ETL for everyone. Some people have got huge analytics workloads running, and for those, ETL will still be the way to go. So the benefits are reduced data latency, like we said, no ETL, and potentially no separate data warehouse. Potentially it could impact our OLTP workload, but testing is obviously advised, and once you've done your testing you can decide whether analytics are for you. So under the covers, how is Columnstore is basically immutable data. So data appears to be deleted. How is this achieved? It's not actually deleted. Deletes are tracked in a structure called a delete bitmap, and when a query runs, the data from your Columnstore is reconciled with data from the delete bitmap, and so you do not see the row that has been deleted. Inserts are handled in a similar fashion. Again, data is immutable. There's really two types of insert. There's a bulk insert where we insert over a certain amount of rows, and that number is 102,400. If we insert that number or a greater number than that, our data basically goes straight into SQL Server and it goes straight into our Columnstore. If we do a trickle insert, however, which is a number of rows below 102,400, a trickle insert puts our data into basically a row store that looks exactly the same as our clustered table, and then the two are reconciled at runtime when you do your query, and that's how it works. The data is reconciled at runtime. So updates. Basically, it's basically a combination of inserts and deletes. But the question that I might get is, doesn't this all get messy? Deleting data and inserting data all the time? And well, potentially on the face of it, it could well do. But there's a process running in the background called the tuple mover, and this periodically cleans data up from your row-based tables that you don't have to worry about. But when you put data into your Columnstore, first of all it will go into these row-based tables, and then the tuple mover will move that data periodically into the Columnstore and keep the Columnstore index up to date. Now we don't have to wait for this tuple mover to work, maybe every 5 minutes or so. We can force it ourselves. We can use an alter index reorganize or rebuild. Reorganize will work mostly and is more lightweight to move data from our Delta store into the Columnstore. And there's a link there at the bottom which documents how fragmentation is defined in a column store. And that's basically if we've got too many rows in our delta store or too many deletes marked in our delete bitmap, this can be what's known as column store fragmentation. So again, a similar word to what we would expect to use in our traditional indexes, but a slightly different meaning. So here's basically a diagram. Picture says 1,000 words. We've got 3 different row groups there, maybe representing 3 different columns. When data is inserted, instead of going straight into the row group, it would go into the delta store, which is on the left-hand side of the diagram there. Basically, it's an underlying structure that looks exactly like our tables. And when data is deleted from our row group, it is marked as deleted in the delete bitmap. And then when you query for data, all the data is either reconciled if the tuple mover hasn't moved it into the row groups previously, or you've not run an alter index reorganize to basically manually get the process done for you. So to summarize, in 2012, non-clustered column stores were introduced, and they were read-only, but people found various ways to work around them. And then in 2014, we introduced the clustered column store index, which allowed us, which were updatable and could be built over a heap. But as soon as they were built over a heap, we had no way of putting additional constraints on there, additional indexes, additional keys. But now, and 2014 also introduced the archival compression. But then 2016 came along, well, will come along in the next week, or maybe less than a week now. I'm in Australia and it's Thursday, so I guess it'll be out this time next week. So 2016 introduced the non-clustered column store, which was updatable. So this was a huge step forward, really. Also, with clustered column store indexes, you can now place additional constraints on the table, which again is a huge step forward. More data types are supported, and more batch mode operators are supported. And the big talking point with 2016 is operational analytics, and that's quite simply the ability to mix a data warehouse workload with a real-time query across an OLTP system. So basically, instead of going directly to your data warehouse to get your queries, you can now go straight to your OLTP system and get exactly the same data and possibly eliminate your ETL workloads, or maybe not. Features by release, probably too many for me to mention here, but if you follow that link, you'll find a comprehensive analysis of what's new in the different versions of SQL Server. Like I said, this is an enterprise feature, but this could be the feature that pushes people from standard up to enterprise. It's got some really really cool things going on here, and the prospect of doing away with some ETL and maybe going directly to the OLTP store is a huge incentive for some people. But testing, like with anything, is pretty much advised. So let's talk about references and where you can go to find out more about Columnstore. We basically just touched the surface. We've been on a bit of a tour of how Columnstore has developed over the last 4 years, and has now come into being a really, really useful feature. There's an MVP from Portugal. I've already mentioned him once. If I pronounce his name wrong, I'll have to apologize to. but he can be found at the URL there. And he's got a multi-part series, I think it might be up to the high 80s now, on Columnstore internals. So the first few entries there, we'll probably talk about some of the things that we've talked about here today, and the later entries would delve deep into the Columnstore index. It says, Nico is responsible for doing the clustered Columnstore index library. It's basically a bunch of scripts that can be run as stored procedures or direct queries, and will examine your Columnstore internals or look at your row-based tables and tell you will they benefit from having a column store built over them. I'd really advise anyone who's now got the taste of Columnstore to go have a look at this library and get familiar with the internals of Columnstore. The PASS Summit in 2014 and 15 as well had some great presentations. Some come from Nico himself on the internals of Columnstore. And if you are a PASS member, you should have access to some of those, or certainly your user groups will, and potentially you can look at them via your user group. Sunil Agarwal, who is the Microsoft PM of the Columnstore team, has got some great content on clustered Columnstore indexes. If you basically just search for his name, you'll find presentations at Ignite, PASS, various places around the world, where he goes into depth on how the clustered Columnstore works and some of the major improvements that have made operational analytics possible and getting good performance of analytical queries on your OLTP systems, which is basically what operational analytics is about. There's a great presentation from the SQL Cat team from PASS 2015, which talks about some customer scenarios, and I believe there's also a presentation from today. Rick Hage is another MVP, done it earlier, where he talked about a real-life situation where Columnstore benefited one of the clients immensely. So now, if you missed that session, I realise it's a 24-hour event. I missed it. I was in bed while that was on. But maybe now it would be a good time to go back and look at that with some of the new knowledge you might have now, and find out how Columnstore technology helped in a real-life situation. There's some more references. These are pretty much all from Sunil. He done a great series of blog posts about operational analytics and Columnstore in general, and some of those would be really cool to read and arm you with some great sets of data. So that's all, folks. That was a bit of a whirlwind trip through the new land of Columnstore, a 4-year journey. So I'm happy to take questions and hand back over to Johan, who's hopefully been making a note of any.
Thank you, Martin. Yes, I have. We've got only 3 questions here.
Okay, that's great.
If T-SQL query uses any index hints, will they affect Columnstore indexes?
The index hints. Well, I get on 2016. If you use an index hint, I guess the optimizer will decide what indexes to use, and if those hints, if it decides to use those hints on those particular indexes, then it will run with them. You can basically mix and match the 2 workloads, so that I can't talk for all hints. I've not obviously tried them all, but they should work.
Okay. If for some queries I don't want this CS index to not be used, is there any trace flag that I can use just for that query?
Okay. You don't have to actually go as far as a trace flag. There is actually a hint that tells the optimizer not to use the Columnstore index. I can't think off the top of my head what that is, but if you search for it, you will find it. I did see there was a great presentation by a guy called Jimmy May at MPAS last year, 2015, and in there he does actually show an analytical query running against a table with Columnstore on it, and also traditional indexes, and he runs it with the query hint to say ignore the Columnstore, and it takes I think it takes probably about 3 or 4 minutes, and then he runs it again with the Columnstore, obviously omitting the hint, and it takes 2 or 3 seconds to run. I am very sorry, I can't think of that hint off the top of my head, but it does exist, and if you search for it, you will definitely find it. You don't have to use a trace line.
All right. Have you observed any scenario where CSI resulted in performance degradation?
Not in a production environment. I've heard about it doing that. Maybe if you run it on tables, with not many rows, or tables with a lot of fragmentation, Columnstore fragmentation, maybe a lot of rows in a delta store, a lot of rows that are marked as delete, so the delete bitmap is keeping track of a lot of rows, then possibly there you'll see some big performance issues. I definitely would advise testing this sort of thing though on a production workload. But it is definitely a likely scenario where there are some instances where a column store may not perform as well as a traditional row store. Definitely.
Does partitioning work the same way for column store index as for row store indexes?
Yes, it works.
Eliminated?
Oh, yes, it does. Partitioning does work exactly the same way as you'd expect with other with row-based tables. In fact, it's a great way of, we can take advantage of partition elimination as well, and as well as eliminating the columns that we don't need, we can obviously eliminate partitions we don't need. And Nico has got some great advice in his blog postings there about how to ensure that different partitions have different struggling for words here. You can kind of get some sort of semblance of ordering your index, so different partitions will have different values in there, and therefore you'll get good partition elimination. So those features can most definitely be used together, and probably they should in fact be used together.
Are there any X events that are exclusively for column store indexes?
Yes, there are plenty of X events for column store indexes, and there was a lot added in 2014, and I believe there's been 3 more added in, or maybe more added in 2016. And you'll be able to see your row groups and other structures to do with column stores, and how columns are eliminated and all that sort of thing. I'd advise people to go away and have a look at the X events. A great way of doing that is to just go to the X events GUI, new session, and then just search for column store, and you'll find a lot of X events there, aptly named with column store in the title.
All right. Any DMVs that are exclusively for the column store?
Yep. Again, there's a lot where you can see your row groups. You can see what rows are in your Delta store, what rows are compressed in your column stores. Again, if you just search, I think sys.systemobjects with a like where clause for column store, you should find at least 7 or 8 DMVs there that you can go query and look at your Columnstore internals. If this session would have been a bit longer, I would have gladly shown some of those, but we unfortunately got about 5 minutes to go.
And could you please just show the last slide of resources again?
Oh yes, sure. Okay, so I've got 2 slides there. Obviously the first one just names a few people. The second one has got, these are mostly by Sun at Lagerwall, but I believe these slides are available as a PDF. So these will definitely be in the PDF and yeah, can be downloaded.
Yep. That's all the questions. Thank you.
Okay, thanks for having me. It's been great talking to everyone. It's a bit strange sitting in a room talking to your PC, but it's been great. And over to you, Johan, to close off.
Thank you. So make sure to stay tuned for our next session, which is Use Cortana Intelligent Today with Chris Testa O'Neill. It's coming up in 3 minutes. And that's about all. Next slide.
Yep.
Yeah. Thank you for attending.